We all celebrated when Chandrayaan-3 touched down on the moon's uncharted South Pole. But as the dust settled, a shadow of uncertainty began to surface. The data quite didn't add up. There were strange heat signatures, sulfur deposits in odd places, and rumors of visuals that were never supposed to be seen. Is this just lunar science at its finest, or could there be more to the moon than we ever imagined? Let's find out. Of course, every mystery has a starting point. And in this case, it begins with Chandrayaan-3's journey to a part of the moon no one had ever reached before. Now, before we get lost in all the theories and speculations, let's rewind for a moment and look at how Chandrayaan-3 made history. Reaching the unreachable, Chandrayaan-3's historic landing. India's journey to the moon didn't start with Chandrayaan-3. It began years earlier with a small spacecraft that made a very big discovery. In 2008, Chandrayaan-1 was created. It was India's first deep space mission. Chandrayaan-1 flew to the moon and found something no one had confirmed before. What was found wasn't puddles or lakes, but tiny traces of water molecules trapped in the lunar soil. This single mission put India on the global map of space exploration. It was a quiet success that changed how we look at the moon. That achievement laid the foundation for what came next. In 2019, India set its sights even higher with Chandrayaan-2, this time aiming to land a rover on the moon's south pole. Everything was going well, until the lander, Vikram, lost control in the final moments and crashed. It was heartbreaking, but not the end. The failure taught the Indian Space Research Organisation, ISRO, what needed fixing. So instead of giving up, they got back to work. Now, this is how the idea of Chandrayaan-3 emerged, not as a fresh start, but as a continuation of a mission they didn't want to abandon. Launched on July 14, 2023, this mission had one goal. It was basically designed to make it to the moon's south pole and land safely. And on August 23, 2023, that's exactly what happened. For the first time in history, a spacecraft touched down near the moon's south pole and stayed in one piece. India became the fourth country to ever land on the moon, and the first to do it in that region. A region no one else had even dared to try. However, you might wonder, why all this fuss about the South Pole? Well, scientists believe this area holds secrets that could change the future of space exploration. Because of how the sunlight hits the moon, some craters near the South Pole are always in shadow. These places are so cold, they might have trapped ice for billions of years. If that ice is real, it could be used for drinking water, oxygen, even fuel for rockets. That's why landing here is not just about being first, it's about opening doors for future missions, including human settlements one day. When the news broke that Chandrayaan-3 had landed, the reaction was electric. Across India, people celebrated in homes, schools, and city streets. Inside Mission Control, you could see tears, cheers, and pure relief. Prime Minister Modi joined the broadcast, proudly saying, "India is on the moon. We have our national pride placed on the moon." The world took notice. It wasn't just India's victory. It was a reminder that space isn't owned by a few powerful nations and anyone with vision and hard work can get there. With the landing complete, it was time for the real mission to begin, one that would unfold slowly, but with surprises no one had expected. A lander and a rover. As we all know, when Chandrayaan-3 landed on the moon, the world celebrated. But for the team at ISRO, the real work was just beginning. The landing was only the opening act. After landing, it was up to two small machines to quietly search for clues in a place no one had ever explored up close. These machines were called Vikram, the lander, and Prajan, the rover. First, let's talk about Vikram. Vikram was the anchor of the mission. It was designed to land safely and serve as a science station, packed with instruments ready to study the moon's surface and the space above it. One of its main tools was called CHAST. This device wasn't designed to look impressive, but it knew how to get the job done. It gently pushed a probe into the lunar soil and measured how heat moved through the ground, inch by inch. This helped scientists understand how the moon's surface handles temperature changes, something that's very different at the South Pole. Another instrument on Vikram was ILSA, a device that listened for moonquakes. The South Pole had never been monitored for seismic activity before. Any tremor, no matter how small, could reveal new clues about what's happening beneath the surface. Vikram also carried a Langmuir probe, a tool that measured the thin layer of charged particles floating just above the moon's surface. It's a strange environment out there, and this probe helped scientists see how the plasma behaves when sunlight hits the lunar ground. But that was only half the story. Pragyan, the rover, was built to go beyond, exploring the surface up close. If Vikram was the base of operations, then Pragyan was the one venturing out, checking what lay beyond. Once it rolled down the ramp, it began scanning the surface with two key instruments. One was APXS, which analyzed the soil's chemical makeup by firing alpha particles and X-rays at it. The other was LIBS, a laser that zapped the soil and studied the tiny plasma bursts that came from the impact. Through this, Pragyan could detect elements like sulfur, aluminum, and iron. This combination of lander and rover was not new. Chandrayaan-2 had a similar setup, but that mission didn't go as planned. The lander lost control during its final descent and crashed. It was a tough moment for ISRO, but they didn't walk away from the challenge. They studied every detail of what went wrong and came back stronger. For Chandrayaan-3, they upgraded Vikram's sensors, tweaked the landing algorithms, and even removed an engine to make the descent more stable. Every mistake from Chandrayaan-2 became a lesson for Chandrayaan-3. This time, the landing was flawless, but what happened next caught everyone off guard. As part of a follow-up test, ISRO instructed Vikram to perform a gentle hop, lifting itself off the surface and landing a few meters away. This was a crucial experiment to see how it would handle liftoff in lunar conditions. During a maneuver, the lander lifted off the lunar surface and shifted itself about 40 centimeters to the side. It was a small move, barely a nudge in space terms, but it meant something big. Vikram had just proven that controlled takeoff and landing on the moon was possible. And that tiny hop opened up ideas for future lunar mobility that no one had thought of before. Together, Vikram and Pragyan started uncovering data that had never been recorded from the moon's south pole. Chase provided detailed readings on how the temperature shifted as sunlight touched the ground, revealing that heat doesn't spread the same way across different patches of soil. ILSA caught seismic signals, sparking questions about whether these were caused by micrometeorites or if the ground itself was shifting. The Langmuir probe showed how the plasma environment changed from day to night. Meanwhile, Pragyan was busy analyzing the lunar soil. When it detected sulfur in the surface materials, it marked the first time sulfur had been confirmed on site at the South Pole. These readings were important because they told scientists more about the moon's volcanic past and how elements got distributed across its surface. This wasn't one of those big, showy space missions. It was basically just two machines sent to quietly explore somewhere we've never been. Every move they made was slow, deliberate, and packed with purpose. What made it even more fascinating was how some of the data didn't line up with what scientists expected. Certain readings raised more questions than answers. And that's when the excitement really began to build. Because when you send a mission to a place no one has been, you can't always predict what you'll find. But in this case, Vikram and Pragyan might have stumbled onto something that could change the way we see the moon forever. Now, while the mission seemed to be going exactly as planned, some of the data coming back began to suggest there was more to this region than anyone had expected. Strange discoveries at the edge of darkness. The first few days on the moon felt like clockwork. Vikram and Pragyan were ticking off tasks one by one, feeding back data that looked exactly how the scientists expected. Apparently, everything was too smooth, that's why no one was prepared for what happened next. The first curveball came from the soil itself. When Pragyan started zapping the ground with its laser, it picked up something no one had ever confirmed at the moon's south pole: sulfur. You'd think it would be a minor detail, but to lunar scientists, sulfur isn't just any element. Its presence could mean ancient volcanic eruptions left traces in the soil, or perhaps meteorites delivered it over billions of years. Either way, finding it where no one had looked before was a big deal. But that wasn't the only surprise. The thermal readings started behaving oddly. Vikram's chased probe was designed to measure how temperatures change as it digs into the lunar surface. What it found didn't match what anyone had predicted. At the very top, where sunlight hits, the surface was heating up to a scorching 82 degrees Celsius, which is far hotter than what ISRO scientists had predicted and much higher than the 57 degrees Celsius they expected. But just a few centimeters below that, temperatures were plunging below freezing. In fact, they dropped to around -10 degrees or even lower. On the surface, it seems simple, but there's more to it. The thing is, the moon doesn't have an atmosphere to spread heat around.